Okay, in this presentation we're going to look at mixed probability distributions. So here we're talking about where over one interval we have one probability distribution and over another interval we would have a different probability distribution. And that's sort of essentially what's going to happen here. So there are two continuous probability distributions. A is an exponential distribution with mean mu equals 7. Okay, now that's exponential. Something we should also immediately consider is that if the mu is 7, that means lambda is 1 over 7. We'll just sort of save that for later on. B is a distribution that is uniform on the interval 0 to 8. Okay, so this B is the one that's actually mixed and therefore thereafter proportional to A. That means after 8 it becomes an exponential distribution. Okay? So show that the probability of a random variable that follows the B and lying between 0 and 8 is 8 over 15. Okay, so just to start us off, this is a revision of the definitions regarding the exponential distribution. So essentially this part here is the key thing there. So lambda here is equal to 1 over 7. Okay, so we're going to use that later on. So that is 1 over 7 times e to the minus 1 over 7 times x. Okay, so just keep that in mind later on. So anyway, we can define the probability distribution of B. Now B is the one we're actually going to be working with. And that is f of x equals c for 0 to 8. That's the uniform component. So I just took a pause there and just back on track here. Anyway, the top part here is uniform and the bottom part here is exponential. I'm just going to write out the bottom part there again. It's k over 7 times the exponential of minus x over 7, because I realize that might be a little bit hard to read. Okay, that's a bracket there. Now, this is important here. Just let's look at this part here again. Okay, we have x less than or equal to 8, and you notice that less than or equal to 8, and over here we have x greater than or equal to 8. So in both cases, we have a scenario, they account for the case where x is equal to 8. That's not accidental or intentional. Actually, that's the way we're setting it up, because it's the only way we can really make things make sense. Okay, and it would make sense in a sort of continuous distribution that they would sync up at the junction points, if you follow me, where they would meet each other. So at x equal to 8, we have f of 8 equals k over 7 times the exponential of minus x over 7, which is equal to c. Okay, so we're going to use that for later on. Okay, now what we also know is that the total area under the curve, we're moving on now, so the total area under the curve must equal to 1. Okay, so we have two components here, and essentially what we're going to do is integrate them both. The limits of integration for the uniform component is 0 and 8, and then for the exponential component it is 8 and infinity. Okay, so for the uniform component we're just going to integrate c, which is a constant, so we end up with c times x, and when we evaluate that we just end up with 8c. Okay, for the exponential component we could take out k here. Okay, so we can actually take out 7, but what we have here, e to the minus x over 7 divided by 7. So actually what happens if you work that through, you get minus k times e to the minus x over 7. Basically that 1 over 7 disappears. So what we have to do there is evaluate that, okay, for between infinity and 8 and infinity. Okay, so a convention is that the exponential of minus infinity is 0, so we can disregard that infinity part. The first part goes to infinity. When we evaluate it for 8, we get minus k times e to the minus 8 over 7. Okay, so that is up here as well. Sorry, actually something I should have put in there. That is equal to k over 7 times e to the minus 8 over 7 there as well. Okay, forgot to put that step in there. So anyway, you sort of notice that we have both. That's something I should have finished with above, and we have that expression there as well. Okay, so what am I saying here? That 7c, going back up here, 7c is equal to k times e to the minus 8 over 7. Okay, that's our conclusion to this top part here. Okay, so essentially what we're saying is we have 8c plus 7c is equal to 1. That means c is 1 over 15. Okay, so over the interval from 0 less than or equal to x less than or equal to 8, the total area under the curve is essentially 8 times c, which is 8 over 15. Okay, so was that the question we were asked? That was the question we were asked. Okay, we'll leave it there.